when you write an exponential function that models a percent change, it's important to identify what the variables represent. In most cases, what we do is we let y represent the total amount. Whatever it is we're talking about, whether we're talking about the value of a car or the number of people with a virus or the number of bacteria in a certain dish, whatever it is, the y is the total amount. And usually x is a time period. Sometimes it's a day, sometimes it's a year, sometimes it's an hour. It depends on the situation. So let's take a look at an example to see what I mean. Your starting salary at a new company is $35,000 per year. Every year that you stay with the company and get a positive evaluation, you receive a 5% raise. Write an equation that models this situation. Okay, so in this case, what are we talking about? Like, what is this? This is the number 35,000, but what is it? Is it 35,000 bananas? What are we talking about? This is $35,000 per year. It's your starting salary, okay? So we're talking about your salary. The y is the salary. That is what the problem is about. Now, the x is the time period. So in this case, what time period are we talking about? Are we talking about days, hours? And I read and I say, oh, every year. So in this case, x is the number of years. Okay. Now, I'm going to identify two pieces before I can write an equation. I'm going to first identify the initial value. Initial means starting, right? Like if you write your initials, that's the starting letter of each of your names. So A is what's called the initial value. So it says my starting salary is $35,000 a year. So my initial value is $35,000. Okay, now I'm going to identify the growth or decay rate. This is what we just practiced. So here, is my salary growing or decaying? Is it getting bigger or smaller? It is getting bigger, right? I'm receiving a raise. A raise is my salary is getting bigger. And how much bigger is it getting? It's getting bigger 5% every year. So if I'm starting at 100% and I'm adding 5%, that's 105%. Okay, and then I'm going to divide it by 100, right? Slash move the decimal place over. And so my growth rate is 1.05. Now, when I write the equation, this is what it looks like. Y equals the initial value, which is 35,000, times the growth or decay rate to the power of x. Okay. Now, the reason this works is because after 1 year, if x is 1, right, x represents years, I'll do 35,000 times 1.05, and that'll give me a 5% raise on this. After 2 years, I'm going to take that number and multiply it by 1.05 again, because the second year, I don't just get a raise on 35,000, I get 5% of my new salary. The next year, I get 5% of my new salary. So at some point, I might be making $50,000, and when I get a raise, I get a 5% raise, 5% of 50,000. So my raise is actually going to get bigger each year. So let's go ahead and do the math. I'm going to grab a calculator. So I grabbed a calculator, and I'm going to go ahead and plug this in my calculator. So I want to know what's my salary. So my salary is y, right? So what does y equal after my positive 1 year evaluation? So that is where the x value is 1. Okay, now I don't even need to write that. Really what I'm going to do here, 35,000 times 1.05. Now I could just press enter. Look, right? This is just 35,000 times 1.05. Now look, if you put to the power of, look, it's that same symbol that's above the 6, right? This is called a caret. To the power of 1, you could type that. It's not going to make a difference. Okay? If I go back, watch, I'm going to delete that. It's the same number. Okay? But after my first year, I'm going to get a raise from 35,000, and this equals $36,750. Okay? So that's my salary after 1 positive year. Now, after 6 years, I'm going to put this in my calculator. Because what's going to happen, look, this is going to get multiplied 6 times. Let's think about how that makes sense, right? I just multiplied it by 1.05. So this is my salary after the first year. Then after that, I'm going to take that number and I'm going to get a 5% raise again. That's after the second year. And then I'm going to take this and I'm going to multiply by 1.05 again. That's after the third year. This is too much work though. Watch what I can do to make it shorter. I can say, okay, I'm going to take my starting salary, 35,000, and then I'm going to multiply it times 1.05. How many times am I going to multiply by 1.05? However many years it's been. That's how many times I'm going to get this raise. So rather than write times 1.05, times 1.05, times 1.05, I can use exponents, right? That's what exponents do. So look, I'm pressing this button. Okay, this button gives me the exponent, and I'm doing to the 6th power. Okay, so here is my new salary after just 6 years. Look how much. You might think 5% is not a big raise, but after 6 years, just 6 years, I've gotten more than a $10,000 raise. This is my new salary, $46,903.35. Okay? Now notice, it makes sense for me to round to the nearest cent because this is dollars and cents, right? So I'm going to round, and this was a 4, but this was a 7, so I'm going to round that 4 up. Okay? So this is my new salary, and you can just imagine that after, say, 20 years, I'm really going to end up making quite a bit of money. You can even look, let's go back. How much would I make after 20 years? Woo, 92,000.